So welcome back to our second session in the Display Innovation Day. This time we're going to hear from 3D-Micromac, from René. So the company does, laser for a lot of solutions in the display industry. And right now we're going to talk about waveguide cutting with lasers for AR. As you can see, AR is becoming a hot topic, and there's a lot of need for novel technologies to get this, industry actually into the market. So thank you, René, and you have the floor.
Yeah, thank you, Ron, for this kind of introduction. Yeah, as Ron already said, my talk is today not about micro-LED processing, but it is about laser cutting as well. It is about laser processing. It's the laser cutting for a singulation of waveguides for AR devices. My name is René Liebers. I'm working at 3D-Micromac as a business development manager. And the results we are showing here are co-developed with the Schott AG. First of all, a short overview on the content on the presentation, an overview on the market, then the approach we are using. The main part is on the process results we got, and then finally I show you a production or volume production machine and a short summary at the end. Yeah, but first of all, a few words on the topic we are talking about here. The target application is, as mentioned, the manufacturing of augmented reality goggles. As you can see here is in an example. And yeah, for sure, the sales numbers of those devices are quite low at the moment still. And this is mainly influenced by values like the bulky form factor, the heavy weight, the low battery, and still unclear use case scenarios. But anyway, the amount of those devices of sold devices are growing constantly. And a lot of new devices also came on the market within the last few months. Big players are demonstrating what is possible from a technology perspective. And therefore, the request for high volume ready processes with high production yield are on the table finally. And the customers transform their R&D processes towards prototyping focused phase and finally towards mass production. This is the goal of the whole industry. Yeah, and to produce those required components for those AR devices, many optical designs use the so-called waveguide combiner. And their function is just to overlay the real-world image with the relevant digital information. And the devices then also called see-through AR devices finally. And as you can see in the picture here, this waveguide technology works in a way that digital image projector emits light or an image towards an injection grating of the waveguide, which is guiding the light via total internal reflection. And finally, the user sees an overlay of the digital image and the real world. And especially in this design, which uses diffractive type waveguides, the so-called eyepieces have to be singulated from a wafer substrate. And before the singulation process or cutting processing step, these wafer pass through different coating steps, such as nanoimprint coating, for instance, or anti-reflective coating process steps. And one of the main requirements is the bending strength of the cut pieces. And after cutting, these lenses are subjected to many additional process steps. They are exposed to mechanical loads through handling or assembly. And in addition, for sure, also between the final use case, they are exposed during daily wear of those devices. And yeah, the technical playground is very large, and currently no single solution is the clear market favorite. And yeah, it's important to know that on one hand, there are different optical designs available. Those were competing at the moment, and yeah, different technologies such as holographic waveguides, diffractive, reflective, and a lot more. And also from a materials perspective, everybody is looking on the best match between performance regarding weight, light efficiency